Welcome, everybody. Tonight we're going to be working on our Chapter 6 exercises. I'm in Eclipse already, and I'm all set to code. So I'm going to start by building a brand new Java project. These are the Chapter 6 exercises, so I'm going to name it accordingly. And I'm going to go with all the defaults here. All right, now that the project is built out, I had to wait for that a second. I probably should have put spaces in that. Oh well, next time. I'm going to go ahead and expand this, and I'm going to add a new class file to our source folder. So there comes the class. And let's look at the exercise description. I'm not even sure what I'm building yet. I'm like just plowing ahead to build it. So we're working on Chapter 6, so I need to go to the book. We're working on exercises 1, 2, 3, 6, and 12. And hopefully we get through all of those tonight. I'm hopeful that we will. So let me get my ebook up on the screen here so we can look at the assignment description. So that'll just take a second. When we do get a chance, I'm going to do a couple of announcements for you guys too. But right now I do want to dig into coding so we get rolling on this. So we're looking at Chapter 6 on looping, and I'm going right to the program exercises here if I can find them. And the first one was exercise 1. So that's a pretty simple one, I think. Make my font just a little bit bigger here. All right, so this says, write an application that counts by 5 from 5 through 500 inclusive. That means including 5 and including 500. And that starts a new line after every multiple of 50. So in other words, we're going to print 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Then we'll go to a new line, right? Instead of just on the list like we were just doing at W3 Schools, right? And then we're going to modify the program afterwards so that the user enters the value to count by, and then we start a new line after every 10 values, and we're going to call that count by anything. But we're going to start with this one, which is count by 5s. All right, so back over in Eclipse, let's call this count by 5. We are going to do a public static void main on this one, right? And I think you'll be amazed at how short and sweet the code is on this. It really doesn't take a lot of code to accomplish this. And I think that, you know, given the fact that we were just looking at those examples, I think maybe already you can see why, but you might not think about exactly how you might accomplish it. What I'm going to do here is, and I'm going to not do this for all the exercises, but I'm going to code this first with a for loop, because that would be what I would naturally go to. And then I will do it with a while loop to show you can do it both ways, right? And please, you know, as you think about that when you're writing loops, generally speaking, you can use either for loops or while loops to solve the same problems, provided that your logic is correct, right? Typically, I would use a for loop when I know how many times I want it to run. This is one of those scenarios. And often I use a while loop where the user might interact with the program and change something like type quit, for example, to get out of the program, and then we react to that, right? So, but in principle, I can accomplish it with either one. So I'm going to start with a for loop. So I'll start with the keyword for. We'll set up our parentheses, and then inside here, first we'll set up our loop control variable, or our sentinel value, if you will. This is basically initializing that variable to a value. Now, the instruction said to go from 5 to 500 inclusive, and then every multiple of 50, we go to a new line, okay? So why start at 0 or 1? We're going to start at 5, right? Because that's the first number we need. And then our logic will be, as long as I is less than or equal to 500, we will keep looping. Notice the semicolons in here, because these are really 3 programming statements we're putting in these parentheses. Remember, this executes before the loop starts. This executes every time the loop runs. It's the condition we're checking. And then the final value is usually an increment or a decrement or changing this sentinel value so that eventually we can get out of here, right? Otherwise the loop will run forever, right? So in this position, we're asked to count by 5. So I'm not going to go I plus plus like the examples that we just looked at. This would just change it to 6 and then 7 and then 8 would go up by 1, not useful for what we're doing. So what I'm going to do is a little simpler. I'm just going to say I plus equals 5. So I'm going to add 5 to I each time. All right, now we're going to follow this with a set of curly brackets. There's our curly brackets. And all of our loop code will exist inside here. So everything inside those 2 curly brackets will repeat every iteration of the loop. Now, I just use the word that maybe you haven't heard before. If you had me in Python, you certainly heard it, right? Because I kind of enforce the terminology a lot. But a lot of us are familiar with this concept of repeating. Another way to say repeat. So for example, is like, hey, let me repeat my words. You could also say, let me reiterate my words, which means to which is to do again, iterate is to do it once. So when we run through a loop once, we call it an iteration, right? When we run it multiple times, it's reiterating, right? So these are like geek terms, but it's good terminology to know because like you're talking to a programmer and you're like, hey man, I just iterated through the code, and you're like scratching your head. They know you don't know how to code, basically. So that's why the terminology is actually important. So what we're going to do every time we go through this loop is we're going to system out. We're going to print to the screen. But if you guys remember, we don't want to go to a new line right away. We're just going to do a system out print, not print line. And we're just going to output I, and we'll concatenate to it. I think maybe I'm speculating here, like a space or 2, so the numbers aren't touching. So it'll come through and it'll print 5 and a space, 2 spaces. Next time through, it'll print 10 because it'll increment in 2 spaces and it'll go all the way across. Then at some point, when we get to a multiple of 50, we're supposed to go to a fresh line. Okay, well, how the heck do we do that? Well, that sounds like an if statement to me. So here comes the logic for that. Apologize for my cold. I can feel my throat tightening up on me here. Like I feel like I need a cup of hot tea. So I'm going to check I each time we go through. And if it happens to be a multiple of 50, so I'm doing a modulus of 50, dividing 50 into it. And if I get a remainder of 0, then I know it's a multiple of 50. And then I will execute this code, which is system.out.println. That just prints a blank line and we're on to the next line and we start over again, right? So let's kind of step through the logic here one more time before I hit the run button. We set up our loop control variable, our sentinel value, if you will, preset it to 5. We check the value. Is I less than or equal to 500? Yes, run the loop, right? So we go in here, we print out the value, 5, add 2 spaces to it, then check to see if it's a multiple of 50. It's not. And we loop again, but every time we loop, we're adding 5. So it's going to go 5, 10, 15, 20, 25, 30, etc. You get up to 50. It prints out 50, a couple of spaces, checks to see if it's a multiple of 50. It is. It does a print line, and then it moves to the next line, and then it starts with 55, 60, 65, etc. It gets up to 100. Next line gets up to 150. Next line, etc. Right. So that's the logic here. Let's hit the run button, see if it works. Right. So hopefully we did this correctly. I have pretty high confidence that we did it correctly, but there can always be doubt and you can always make mistakes. So let's go ahead and save. Here comes the output, and you can see it did it really, really fast. But it's pretty impressive when you start to think about like what this just did with very, very little code. So it did 5, 10, 15, 20, all the way up to 50, and then up to 100. And then once it got up to the hundreds, the columns kind of even out. But it did accurately go 50, 100, 150, 200. And is it incrementing correctly? It sure looks like it. And it did go all the way up to 500. Now, isn't that pretty slick, right? Very little code, lots of bang for your buck, lots of output, right? And so when you're programming through a problem and you're figuring out how to do something, and you can, instead of having individual little print statements for all of these things, right? Once again, why do we loop? This is a whole lot more efficient, right? It takes a little bit of practice to get used to looping in any language, right? But the concepts, if you get it in Python, which I'm sure you guys did, or JavaScript or PHP or whatever languages you took, it's really kind of the same thing. It's just slightly different syntax approaches because it's a different language. Now, as I promised, we can also do this with a while loop. While loop operates a little bit differently. So the first thing we'll do is we'll set up another integer variable. This time I'll call it j, so we don't like step on the toes of I. And we'll set it up exactly the same way. We'll set that value to 5. And then I'll set up the while loop, and I use capital W, my mistake, lowercase. We'll set up our condition, and the condition is going to be the same one we have above. We're going to say I less than or equal to 500. Right, so while that's true, we will loop. Okay, much less of a declaration here versus the for loop above, right? There's, this is maybe cleaner. I'm still doing this part, right? I'm just doing it outside the loop. I do it before, but if you remember the criteria here, this happens before, right? It just happens to be in the statement. So, yeah, you can collapse this down. You don't need the white space in there. And then I noticed here, I put in I, it should be J. All right. Now inside the loop, we're going to do the same exact stuff. We're going to do the system out print, not print line, but print the letter. In fact, all this stuff is the same, right? This logic is the same. It's not going to change. So I can copy it all down. One difference is the increment, this little piece, has to happen inside the loop here, and we need a semicolon at the end. So now watch, I'm going to run it again. And here, let's see if we can get that while loop a little farther up on the screen so we can kind of look at it while we're running it. But when I hit the run button, what's going to happen is I'm going to get this output twice now. Right, so let's hit the run button. And there it is. It says errors exist. Oh, so I got a bunch of errors. Okay. What are my errors? Oh, okay. See, I did the IJ thing again. So isn't that fun? Like you copy code from somewhere else. But this is actually a really good teaching point. I didn't even look at the underlines, did I? I just like, I'm good. I'm all confident. But I forgot that I switched letters. So when I get inside this block of code defined by the curly brackets, then I must use this variable name. I is not accessible here. So let's Control Z that. Okay, we'll switch that to J, switch this to J, and switch this to J. And the other thing, the takeaway from this is, yeah, it broke, it didn't work. Don't go into a panic mode when that happens. There's a reason for it. Just be systematic and look at your stuff. You can figure it out, right? If I did happen to use the same values here, I would get an error potentially in this spot, but I don't think it would conflict. Okay, now let's try to run it again. We'll do the same thing again. Here comes the run. It's going to ask me to save. And here comes the run, and I should get that table twice, right? So there's the first version from the for loop and the second version from the while loop, but they both accomplished exactly the same thing. So that's my grander point. You do it with one loop or the other. It doesn't really tell you which one to use, right? If it did and I missed it, well, I apologize. But it doesn't say which one to use. So if you did it with a while loop, great. If you did it with a for loop, great. Both can work. Yes, I could switch it to a do while loop. I'm not really too concerned about that. All right. Now we're going to create another program called count by anything. In this case, we're going to prompt the user for a value and then basically do the same thing, but with different numbers. So back over to Eclipse. And here we'll create another new class file. And we're going to call this count by anything. Public static void main. And finish. Let's start by the fact that we're going to have to prompt the user. So I'm going to get my scanner in there to get input. Underlines red. You can do Control Space in Eclipse to pull in the scanner library. You saw it pop in up there. It's my favorite way to do it, by the way. It seems to be the easiest. Remember, if you don't like doing it that way, you can always do the hover and find the right. Yeah, it's not even finding. That's interesting. It's not finding the right thing. All right. Well, you know what? Let's do control space. That seems to work better. All right. Let's go ahead and call this input. And we're going to instantiate a new scanner with the system in library. Grab stuff from the keyboard, basically. I'm going to prompt our user and say systemout.print. And I'm going to say, please enter an integer to count by. Let's give them a standard little setup here. All right. Now we want to capture that value. A lot of times what I do is I'll set up a variable first and then put a value in it. In this case, I'm going to do what most pros do. Most pros do this. They just declare the variable and put something in it right away, like this. So we'll take the input from the keyboard. We'll do the next int command. So the moment they type something here and press enter, this command absorbs it and then stores it in this variable. All right. Now that we have the value to count by, so instead of counting by fives, we can count by threes or tens or whatever, we need to start our loop structure. I will start with, well, let's think about this here. This is kind of a weird little problem, so maybe this is something you haven't thought about. Now, I'm going to go ahead and use a for loop for this because that's where my brain goes, because I consider this to be a finite amount of running, because it's basically going to like generate this much content with different numbers, right? And how far we go with it is up to us. But here's the weird part. When we did this program, we knew what numbers we were working with. We knew we were going from 5 to 500, right? That's not the case with this one. We don't know what we're going up to. Does it tell us what to go up to? Start a new line after 10 values have been displayed. It doesn't tell us what to go up to. Well, that's really kind of bizarre, right? So what I noticed from the previous exercise, because we have to have some sort of stopping point, is that a wise thing to do is look at, like, how many times did we run the count by 5? Well, it was basically whatever we counted by times 100. So it's the number times 500. So that's what I'm going to do here. So that's how I'm going to run my loop. So I'm going to start building a loop. I'm going to say for, and we'll use, once again, int I as our thing. Now look at the difference here, because the user entered in the value. We don't know what they're going to type, right? And so I will be equal to whatever they typed in. It's same logic. But now we're going to check I as less than or equal to that number times 100. So if they type in 3, we're going up to 300. If they type in 9, we're going up to 900, right? And then we're going to increment by how much? By that number each time. So it's going to be I plus equals the number. Okay, now we're going to do open curly bracket, press enter. You got your closed curly bracket automatically. And now we're ready for our code inside the loop. Okay, same thing we did last time. We just do a, system.out.print, and we'll output I, and we'll concatenate a couple of spaces after it. So that'll happen every iteration. Now, we probably want to increment the counter. So this is kind of, we're running into like a little problem here, and I don't know if you guys are detecting it. So modify the application so the user enters the value to count by, start a new line after 10 values have been displayed. Well, in the previous problem, all we had to do was divide by 50 because we knew we were looking for that, right? So we could just hard code it in there. Here we don't have that advantage. So now we have a different problem to contend with, and that is after every 10th output, we have to go to a new line, right? Regardless of what the multiplier or divider is. So there's a different thing we're going to do. So I'm going to come outside the loop here. And actually, I'm going to arrange my code kind of like this. I'll keep these variables separate. I'm going to do another integer, but I'm just going to do a counter, basically. So I'm going to call it count. I'm going to preset it to 0 before the loop starts. Inside the loop, every time I print out one of those numbers, I'm going to increment the counter. So I'm going to do count plus plus. That adds 1 to the counter. Okay. So every time that prints out, it adds 1 to the counter. Now I got to check, has it done it 10 times? So I'm going to say if the count is equal to 10, then we'll print a new fresh line. So then we do system.out, not put, but out.print line, and nothing inside of it. We're just going to a new line. And then we're resetting the counter back to 0 so we can start over again, right? That only happens every 10th time, right? All right, believe it or not, that's all of it right there. You're seeing it on the screen. I'm going to zoom out just a tad bit here. See if I can do that so we get more on the screen. So if you guys are still copying code, there's the whole for loop. I'm going to go ahead and save this and hit the run button. Let's see if it worked. All right. We are going to get prompted here. And then it says, please enter an integer to count by. I'm going to use a small number to start with. So I'm going to do like something that's easy, like 3. Right? Press enter. And there you go. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. That's 10 times. And then we go to 60, 90, 120, etc. And there you go. And it's basically the same thing that we did. Now, I know some of you are looking at this and going, man, wouldn't it be nice if that stuff lined up? Well, we could write if statements that would determine if it's less than 100, that you add a third space, right? That's a little overachieving, honestly. So we're not going to do that. But if you wanted to really make your columns line up, it's totally achievable. Just a matter of logic and programming. All right, let's try a different value. Let's try something a lot larger, like 25. That's kind of a weird one. I don't know if this will break it, but it sure doesn't, right? And now it's counting by 25s, 10 times on each line. And then after we reach a multiple of 100, we quit. I'm going to pause the recording here for just a second. All right, we're back. We just checked a couple of issues that some people were having and fixed them. And hopefully you guys got this code to work too. We're going to move on to the next exercise. Our next exercise is exercise 2. If I remember correctly, I should probably check that, right? Don't take it on faith, make sure, right? So it's exercise 2. So we do the first 3 and then we start to diverge. All right, so in the ebook, exercise 2 says, write an application that asks a user to type an even number or the sentinel value 999 to stop. When the user types an even number, display a message that says, good job. Then ask for another input. When the user types an odd number, display an error message and then ask for another input. When the user types the sentinel value, or the value we're looking for, which is 999, end the program. Right. This is really kind of an interesting one because for this one, you know, my brain says you're using a while loop. And now, granted, this is with experience, also because I'm looking at the solution, but this is a really common type of loop to use when you want a program to keep running. And I want you to think about what I'm saying here, right? Like, so if you, like all the applications we've created so far, it's kind of like you run the application and it's done. It's like, oh, wow, did it work? Did it not, right? What about if you wrote an application like, you know, let's go back to rock, paper, scissors. Like if we had this for rock, paper, scissors, we could put the whole game inside of a while loop and then say, play again. And then you just, you know, right. And then if they say no, you're out. If they say yes, you keep playing. If you say no, you're out, you know, that kind of thing. So that's why this exercise is particularly useful. So this is the first time that we're encountering something like this. We're going to call this even entry loop, kind of an odd name, but hey, we'll go with it. So a new class file once again, and we're calling it even entry loop. All right, public static void main and finish. Inside here, we already know in advance we're going to do a scanner. So let's just get all those mechanisms in place. Control space. There's the library. I'm just going to follow all my standard conventions here. We'll just say new scanner system in, not ohm, but in, and our semicolon. We are going to prompt our user. Yeah, I'm going to switch to copy pasting here to accelerate workflow a little bit so I can just talk a little bit more. And we're going to put this message on the screen. And we're going to say, please enter an even number or 999 to quit. Right? I don't know why we chose that value. That's the author's choice, right? We'll capture that value and store it in this variable called num. From there, we go into a loop. Okay, so watch the syntax on this because this value that we just captured from the keyboard, right? Unless they start a program and immediately type 999, which probably isn't going to be the case, is basically our sentinel value sort of in reverse. Now, this is kind of a weird concept, so follow with me here. So what I'm going to say is we're not checking for the number. We're checking to see if the number does not equal 999. Because if it does equal 999, don't run the loop. They quit. See my logic here? So here's where like reverse logic comes into play a little bit. And conceptually, this sometimes can be a little bit of a leap for people. I'm also noticing I'm putting spaces here, and normally, I think in Java it's not really expected, but it does work. We'll do the same thing that we did before here to determine an even number, right? So the way that you determine if something is even or odd is you just run an if statement and mod something by 2. If the remainder is 0, it's even. Right? So very simple little if statement. So we'll say if num mod 2 is equivalent to 0, and I think they gave us a message to type, and you know what? I'm just pasting it in. I'm being extraordinarily lazy here. And I'm just going to output, good job, right? That's what it told us to do. But if it's not, right, let's do an else. Say else. You need some sort of an error message, and you don't have to say error, but you could just at least tell them, hey, this is not an even number. Maybe try again. I don't know. But so we got their value, put it into the loop. We said good job or bad job, right? And then what happens? If I left this loop alone, what would happen at this point? This loop would just keep running over and over and over again forever. It would never stop, right? You have to there's some keyboard shortcuts. By the way, if you do get a loop that you run and it doesn't stop when you're in the console, Control C is what stops it. Okay. I could actually demonstrate that. This is probably not wise, so you guys should not do this at home. It's just better to watch, right? So here it is. I'm going to type in a number. I'll put in an even number. It doesn't matter what number I put in, but yeah, if you're not catching it, it's just saying good job forever, and it's not going to stop. And if you watch my little scroll bar here, eventually it's just going to keep going and going. So I have an infinite loop running right now. You can stop it though, right? Click into the console, Control C should break you out. So let's see if it did, because I'm going to go down to the bottom now. And no, it did not, right? All right, so maybe that's not the command key in here. All right, so thank God they have this little button, which is terminate. So I'm going to stop the console from running. And that actually stopped it. But so if this happens to you, don't restart your computer, hit that little red button. Right? I thought the command was Control C. Maybe somebody can just double check that for me. Most consoles it is, but whatever. Separate issue. All right, so in order to get out of this loop, we have to do something to get out of this loop. Now, the other loops, we were incrementing stuff. That's not going on here, right? We're not doing math or printing out a table of numbers. We're relying on the user to terminate the loop, right? And so what we'll do is we'll redo the prompt and the capture of the data. I am going to remove the integer declaration, but basically we're just going to reprompt them and store that value, right? So it's up to them to type 999 if they want to quit. Otherwise, they're just going to get asked over and over again. And by the way, I think it's a good idea at the end, at least, when you're done with the loop, is to show some sort of a message that you're done, right? So I'm going to say, maybe it's better to say program complete, kind of like Star Trek, right? Program complete. Goodbye, right? Or thank you, come again, or something like that. And yeah, I'm not forgetting this time. We do input dot close. And I've been forgetting that, but whatever. That's a good idea to add to every program, by the way. All right, let's look at the difference now when we run it. So I'm going to hit save, hit the run button, right? I'm going to type a 2, type a 3. So we see good job, and this is not an even number. Then we'll type 55 or whatever, whatever number I want. Yeah, what happened here? I put in a number that was way too big for the integer variable, or I hit a string or this. Okay, so let's try this again. I want to get to the point where I kind of demonstrate the 999 thing. So now I'm still in the console here. I'm going to click 999, and the program is done. Right. Let me pause the recording here for a second and see how you guys did. All right, we're back from our little break here, and we're going to do the next exercise, which is exercise 3, and it says write an application that displays the factorial for every integer value from 1 to 10. A factorial of a number is the product of that number multiplied by each positive integer lower than it. And for example, 4 factorial is basically 4 times 3 times 2 times 1, or a total of 24. And if I did 3 factorial, it's 3 times 2 times 1. You kind of get the picture. You basically count down and multiply by each number, and then whatever your total is, that's called a factorial. And if you hate mathematics, and you read, this description, and you're like, oh, you get like the math panic going on. But then when you see it like this, it's like, oh, that's really simple. And it really is truly very simple. It's all in definition. So you learn a little bit about math here, and not to be afraid of it, right? And learn how to manipulate it with code, right? So that you don't have to do the math. That's the logical thing. All right, we're going to do a new class file once again. Let's call this factorials. And we'll throw in our public static void main. Get rid of that comment here. And we have no reason to prompt our user in this exercise. This is just kind of a brute force coding thing. However, all right, so here's where the however comes in. If I write a loop to do this, and it seemed like this would be kind of easy, but this is kind of hard coded is kind of what I'm trying to point out. So we wanted to display the factorial for every integer value from 1 to 10. So we'll start with 1, and then we'll go to 2. The 1 will go 1. Okay, well, it's just 1. 2 will go 2 times 1, which is just 2. 3 will go 3 times 2 times 1, which is 6, right? And we're doing that all the way up to 10. So the loop is running a predetermined number of times, so it screams for loop, right? See the logic there? Now, there's a little hack to this, right? Because you might not figure out the fact that when we're doing this process of like lowering the number by 1 number each time, that's also a repetitive process. So we're looking at a loop inside of a loop here. So this is our first example of a nested loop in programming. Right. So let's start with some basics. Set up an integer variable called factorial. Right. Not putting anything in it. We're going to populate this later. Right. This is just where we're going to store stuff. Set up a for loop, like we talked about. We'll do an int I, and we're going to preset this to 1. Why? Because it told us to go from 1 to 10. So we're starting at 1. Right. Our logic is going to be as long as I is less than or equal to 10. We'll keep the loop running. So we're going to go from 1 to 10, basically. And to do that, we're going to increment I by 1 each time we go through I++. Open curly bracket, press enter. You got your closing curly bracket there. So the first thing that we're going to do is we're going to set the first factorial value. All right. So this is, I would not expect you, real frankly, for most of you, unless you're a mathematician, to be able to figure out the logic of this on your own. So what a lot of people do is they end up Googling it. And real frankly, if you Google factorials and end up on Wikipedia, they give you, I don't know if they give you Java code, but close, right? They give you the logic for it if you want to write code. To begin with, we're going to take our factorial variable and we're going to set it to whatever the current value of I is. So we start at 1, 2, 3, 4, 5, all the way up to 10. Right? Then, based on that value of I, we're going to run the second loop, which is going to be our countdown loop. That takes us from the value of I down to 0, decrementing each time. So we're running a reverse loop here. So watch this. For integer j equal to I minus 1. Okay, we got to talk about this. Why I minus 1? Okay, well, here's why. If I'm going to take the value of I, right, and I want to run a loop up to a certain point, I, at some point, will reach 10, right? And we want to subtract 1 from it in order to keep the math correct. So in other words, I don't want to have that included. I want to drop the value by 1 to get the right value inside the thing. So in other words, if I'm doing 3 factorial, the first number I want to process is 2. 3 is already given, right? So we're at 3 times 2, so we got to subtract 1. See what I'm doing? Right. Okay. Hopefully that made sense. Maybe my first explanation wasn't as clear as the second, but sometimes you have to say it 5 times to get it right. So our condition check flips. Notice we don't go from less than, we go from less than to greater than. So now as long as j is greater than 0, we're going to count down on this loop. We'll stop when we hit 0. And then what we will do is we will decrement each time. And now I copied this originally from the author solution, and the author was doing a minus minus j instead of j minus minus. Now, I'm going to show you guys, it doesn't really matter which order you do it in, but if you study these incrementers and decrementers, the plus plus and the minus minus, it is a thing to either do it before or after when you do the minus minus. So in other words, this will technically add the value after you hit this point, where if I did minus minus j, it would add the value, or subtract the value before you hit that point. Functionally, it doesn't really make a difference in this loop. So I found it curious that the author did that, but there are times when you do that it is very, very relevant. So the math inside here is basically we're going to take the factorial that we have, which is whatever the current value of I is, and we're going to multiply that by the value of j at this point in time, and then it will loop. J will reduce in value until, as we keep going down, so it'll go 3, 2, 1, etc. But then when it reaches 0, it stops, or never reaches 0. It gets to 1 and it stops. And so that will do all the math and store it here. Then all we really need to do is output the result. And I'm actually going to do that inside the outer loop. And listen to that terminology too, right? So when I have a loop inside of another loop, we call that a nested loop. So in other words, we have an inner loop and an outer loop. So that's kind of what I'm referring to. The first few times you do like nested loops, they are real frankly kind of confusing. But once you get the hang of them, especially on 2 levels like this, are really not that hard. Where it becomes a little bit more of a mind thing is when I take another, let's say I put another loop inside of this loop, and then maybe another loop inside of that loop. Is that allowed? Yeah, totally allowed, as long as you can reason your way through it and make it work for what you're doing, yeah, it's completely allowed. Um, I think what happens with most people though is once they get past like 3 of them, they don't get it anymore because it gets too deep, right? It's like really hard to conceptualize. So it takes a lot of planning. A 2-level nest like this is not that bad. By the way, this is all the code. That's all there is to it. Not a lot. Let's run this. And this basically is just going to output the answers, right? And we can confirm these values if you want. So you can go out to, Google or wherever and confirm this. But if you look up the factorial of 1 is 1, I think we already talked about this one and this one. Is the factorial of 424? Well, the book says so. So I trust that's correct too. But is the factorial of 5 120? Well, let's think about it. 5 times 4 is 20. 20 times 3, 60. 60 times 2 is 120. 1 times 120 is 120. Right? So that is correct. So I'm going to assume that all of these are working correctly. But you see how exponentially large the numbers get very, very quickly with factorials, which is why we're not going past 10. Right? You could hypothetically do that, though. All right. I'll tell you what, we're going to take a break right now, and we can field any questions on this when we get back. But I'll leave this up on the screen if you guys want to work from it. Let's take a 5-minute break. I'll see you guys in 5 minutes, about 9:08 or 9:09. All right, we're back from our break, and we're going to move on to the next exercise. And I'm trying to recall which exercise we're working on here, so I'm just going to take a quick peek. We're going to work on exercise number 6 next. So in the ebook here, exercise 6, well, this looks like a silly one, but a fun one. This is kind of an interesting little problem. It says, write an application that uses a loop to create the pattern of O's shown in figure 632 below, in which each O is displayed one additional space to the right of the previous line. Now, this looks like a really kind of simple little algorithm. It kind of is, but it takes a little bit of conception to think about this. Like, how would you accomplish this? All right, here's the thought, right? I could write a loop that outputs an O. And the next time I do the loop, I could do space O. And the next time I do a loop, it could be space O. All right, that doesn't sound too hard. We maybe have a variable that counts the number of spaces and we increment it. Okay, true. But, okay, so here's the but. How do I take a counter for the number of spaces and actually convert that to spaces? Well, there is no direct translation. So I can't just take a number and say, hey, I want 10 spaces, and it just creates 10 spaces. The process of creating those spaces is also a loop. So we are going to be looking at a nested loop structure again. So this one's actually going to go pretty quick too, right? So nice, concise little exercise, but kind of neat stuff to do here. So let's go ahead and create a new class. We'll call this diagonal O's, kind of like that. I don't know if that's really a word, but I'm making it a word. All right, public static void main, so we can run our program. No interaction with the user is necessary here, but we got to start thinking about a couple of things before we start running loops. Now, whenever we run loops like this that are kind of predetermined in structure, and you know what, I should go back to that instruction set because there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lines of O. So we're going to iterate at least 10 times, right? I'm trying to use that terminology again. I'm not sure what this does. Okay. Not sure why that's necessary, but I was curious. I had to click it. Yeah, we're just trying to create that basically. So back here, we'll start building our loops, but now we do want to count at some point the number of spaces. So I'm going to actually pre-create a variable here called spaces that will be an integer, and I'm going to preset it to 0. We don't want to like print any spaces to start with, so we're going to set that number to 0. Now we're going to go into our for loop, and I'm going to say for integer, and I'm, instead of using I and J, I'm going to use different letters this time. I'm going to use the letter A, and we're going to start at 0, and you'll see my logic here as I kind of build this. So our first outer loop, we're going to start our loop control variable at 0. The logic we're going to check against, and I think I counted them, there were 10 of those O's. We're going to go from 0 to 10. Well, we want to create 10 of them, but if we're starting at 0, we don't want to say A is less than 10 or less than or equal to. We want to say less than. So we want to say A is less than 10. Right. Then we will increment A each time through the loop, and we'll do our curly brackets here. All right. So every time this loops, I want it to output the letter O. Okay, well, that sounds pretty easy to me. So you notice I'm putting a line in there. There's a reason for that. So I'm going to do system.out.println. And I should have used my new print line trick, right, Ryan? And we're going to output the letter O. Okay, well, capital O, I think it is. But either way, it doesn't matter, capital, lowercase, whatever. All right. All right, so every time we run this, it's going to output O. Could we run this already? Yeah, we could totally. Let's run it. Okay, let's do that. There it is. 10 O's. All right, great, wonderful. But now we got to get those spaces in there. All right. So the question, when I looked at this problem the first time, and I think a lot of young programmers or people who are just kind of doing this the first time, these are, simple problems, but also kind of interestingly challenging logistically. And this is why I assign it to you guys, because there's little nuances to this which are kind of tricky. So the first time I do it, that's in the right spot. But the second time I do it, I want a space here and 2 spaces here, etc. Right? How is it I can actually do that? And okay, so the initial inclination, this is how my brain thinks, is okay, I'll put an O on the screen, and then after that, I can run, hold on a second, I'm going to run a loop maybe here to output the spaces, but I don't need spaces after the O. I need spaces where? Before the O. All right, so this is kind of an interesting problem, but at the same time, I don't want one on the first line. So I am going to put a loop here, and I'm going to set up a separate loop control variable called B. I'll preset that to 0 also, right? Because this will be responsible, this inner loop will be responsible for printing the spaces, not the O's. Now, I'm going to run this as long as B is less than the number of spaces. And then each time through, increment by 1. And then let's do our curly brackets here. Gosh, I just keep hitting the wrong key twice in a row. All right, there we go. All this loop's going to do is output a space, but I'm not doing print line, I'm doing print. It's going to stay on the same line. Right, so if I need a space, it'll print. If I need a bunch of spaces, it'll print all of them, and then I print the O, right? Because if you look at that chart, wherever that went here, right? Whatever spaces we print and then the O, whatever spaces we print and then the O. Do I need to print anything over here? No, not at all. Who would ever know, right? Because it's blank. So that's a good spot for it, but will this work? Well, think about this. If the first time through B is set to 0 and spaces is set to 0, is B less than spaces? It's not. So this won't even execute. This loop will never run the first time, right? So it'll output O once like this and finish. But then if we want to increment the number of spaces, so I'm going to do spaces plus plus. I'm going to add 1 to spaces. That's all that does. Now the next time through, spaces is 1, B is 0. It'll run at least once and give me a space, and then it'll print the O. And then this number will keep going up, and then it will always print the correct number of spaces before and create the diagonal. Yep, that's all the code right there. Got it. Not a lot of code, but conceptually, kind of a lot going on here to kind of figure through, right? Let's run it and see if this really truly works. So we're going to save this code. And there it is on the diagonal, right? Pretty clever, but yet simplistic, but also pretty powerful, right? So it's all about the logic. You might not see it like, and that's why I was saying, like, if you're a new programmer, you might not see this as a solution this way. Like your inclination is to try to put it after, right? That would be my natural thing. But then when you start to think about when it puts the space in, we really do need the spaces before, because that's what pushes it over. So it has to be before. And yeah, in a loop, because sometimes we only need one, sometimes we need 10 or whatever, right? So that's why it works. I'm going to assume you guys are okay with this one, right? No questions or hands. All right. Let's move on to that last exercise, you guys, and call it a night after that. We're going to move on to exercise number 12. And this one's kind of an interesting one. It says, assume that the population of Mexico is 128 million and that the population increases 1.01% annually. Right. Assume the population of the United States is 323 million and that our population is reduced by 0.15% annually. Now, when I think the author wrote this book, those numbers were accurate. I'm really curious to see what those numbers are now. In fact, you know what? We got enough time in class here to actually look it up. So let's just do population of the US. All right. So right now we're at 331 million, right? So, what I'm telling you is like the information in this book, according to this, we would be less than this now, right? But we actually have grown, right? For whatever reason. The population of Mexico, what's that? So the population of Mexico, well, that's pretty accurate. That's kind of weird, right? So I'm not sure where they came up with those numbers. I think they were estimates, but whatever. Let's just assume that those things are correct. But you see that Mexico certainly has a growth in population that seems pretty steady. And I think it's really fascinating that they have like Russia and Canada here. And you notice how like Western countries tend to have more stable populations, and countries like Russia are maybe even declining or leveling off, where a country like Mexico, where the birth rate is high or whatever, I don't know why there's such growth. They're just more fruitful people, perhaps warmer weather, probably. But I think these are really fascinating little statistics. And when you pull it up on a chart like this, so like when you look at USA is actually on a pretty good upward tick too. I think it's kind of interesting, right? Because we get lots and lots of stats that tell us that the population is leveling off in a lot of developing countries. There is a lot of push, of course, to try to limit the population growth for a lot of different reasons. A lot of us, and myself included, I think I'm of the opinion, because my parents were immigrants. I'm like, why are we keeping immigrants out? I think that the reason this country is great is because we have immigrants, for example. So let's bring them in, so all right, but these are kind of interesting to look at, but we'll just go with the numbers they gave us and assume that their thing is correct. Really what they're trying to assert here is that at some point in the future, the population of Mexico will eventually be greater than the population of the US. And how many years will that take? That's really kind of the problem. So if I go, let's go back to the browser here, right? All right, so we assume like this growth rate annually for Mexico, this reduction rate for the US. I think we've shown that that's not really the case. Write an application that displays the populations for the two countries every year until the population of Mexico exceeds that of the United States. All right. All right. So this sounds a little more complicated, but let's think about this really carefully. Is this a loop where we would know how many times it specifically will run? I'm going to say no. We really don't know, right? Unless you can do like math in your head, like really, really fast. We don't know how many times it's going to run. So a for loop is probably not the right tool. What would be the right tool is probably a while loop. And how long are we going to run the loop, right? Okay, well, it says right here, until the population of Mexico exceeds the United States. So the while loop will be something like, While US pop is greater than Mexico pop, do the math and output the stuff, right? Is really what it is. All right, so I'm going to step through this incrementally. This is kind of a fun little problem. And let's jump over to Eclipse here and let's make a new class file. So right click, new class, and we'll call this population, I think is what they wanted, population. Public static void main, so it will run. And let's start building. All right. Let's take some of the stuff that's already given, right? So they gave us a couple pieces of information, and I'm just going to paste these in. So I got these pre-created over here on my other screen. I'm just too lazy to type, but they said that the Mexico population is about 128 million. I'm truncating it. I'm just saying 128, knowing it means millions. The same with the US population. Now, real frankly, I put these in as doubles, okay? But you're looking at them and you're going, but Ty, those are integers. Like, yeah, they are, right? But when we're working with really large numbers and trying to scale them, we will get much more mathematical accuracy if we use doubles than if we use integers. So that's why I chose that. Right? We were also given the rate of growth for each country. And Mexico's rate is 1.01% growth, and the US rate is, was it point what, I forget where I have to look. I'm sorry. It was like 0.15%. So not even 1% decline, and just a tiny little bit we're losing each year. So these are given pieces of information. And so I'm going to, once again, I'm going to copy paste these in. Now, because these are given, we assume that these values are not going to change, like this growth rate will be consistent. That might be a flawed assumption. And I think really if we consider when the book was written and we look at the rates that were on those charts right now from Google, I mean, it's kind of contradictory. So always take, whenever anybody shoves data in your face, by the way, you always got to take a look at it and make sure they're giving you the real stuff. Now, the first thing you'll notice is, okay, I'm converting the percentages to decimal values. I'm turning them into doubles. I'm also making them constants. I could argue that this is maybe not a good way to do it, but you know what? Let's assume it is a constant rate and work with it. Mexico's rate is positive, right? And right, if you're doing percentages, you always move the decimal place over too. So this is 1.01% or 0.0101, right, as a whole number. Now with the US, we're having a decline, but I put in the rate as a positive number, and then I will mathematically adjust it downwards, right? If you guys feel what I mean, right? So we'll let the math do the negativity, but this is the rate of change, whether it's positive or negative. Okay, so those were our givens. Now we're going to be kind of stepping through a loop here, and I think I've already determined I'm going to do a while loop. And we're gonna have a number of years that we're doing this. We don't know how many years it's going to run. I'm going to set up a integer variable just called year, where I'm going to track how many years it takes. I'm presetting it to 0, right? Because we're going to start counting from today. All right. Next thing I'm going to do is I'm going to move down to our loop. All right. So I'm going to start building my while loop, and I'm going to say while. I already figured out the logic on this from what we were talking before. I don't know if you guys caught that. But while the US population is greater than the Mexico population, we will keep running this loop. Okay, so what does the loop look like? All right, first, we'll take the Mexico population and grow it every year. Okay, so we're going to take Mexico pop, and that will be equal to, all right, so, I feel compelled to talk about this before I just put the math on the screen. If I were to walk into a store, and I do this because I just don't think a lot of people know how to do this, but this is really good common sense math, you guys. All right, so you walk into a store, and you buy something for $1, but there's sales tax on it, right? How do you calculate the tax? Let's say the tax is 5%. I take $1 and I multiply it by 0.05, but that doesn't give me the total. That gives me the tax, right? So I take the amount, I multiply it by the rate, right? And I get the amount I need to add to the amount. Right? And there's kind of like a hack for this, by the way. So what a lot of people do is, because then we still have to add 1 back to it, but you could multiply instead of multiplying. So in other words, I would add 1 to it to get up to $1.05, which is what I would pay at the register, right? But there's a more clever way to do it. If I buy something for $1, I still have to add it back to itself. So I would multiply instead of by 0.05, I would multiply by 1.05, and that gives me the same value, right? Now I'm using number 1, so the math is really easy, but you kind of see the point. Now, the math I'm going to do here, now you can handle it a few different ways, but this is how I did it last time. We do have to include the original value, and then we will add to it the tax rate, which is the original value multiplied by the Mexico rate. And we're adding this to the value that we have. So we're adding to the population, right? If it helps you, really what is happening here with the order of mathematical operations, this operation happens first. So you could put parentheses around it, but because it's a multiplication, that'll happen first automatically. An experienced program would recognize that immediately and just not even put the parentheses in. It's not necessary. We also have to do the same thing with the US population. This one I'm going to copy and paste in, by the way. Same exact equation. The only difference is instead of adding the growth rate, we're subtracting the reduction rate, right? So this is reducing the amount. The other thing that we're going to keep track of in the loop is which year we're on. So we're in year 0. Every year we do it, another year goes by, so we add 1 to the year so we can keep track of how many years it takes. And then every time it runs through, and see, I'm a big fan of this, is let's see what the values are each time. So I can see the populations change as we run the loop. So start at this number, US, and then every year you can see how it changes. Right? So I'm just going to do a system out print for that. So here's my system out print line on that one. Yes, I'm copy pasting. So we'll indicate which year it is, year 1, year 5, year 10, whatever. Space, Mexico's population, and the US population. Okay, that's going to be a little awkward. Okay, and so I'm going to put this out here. Last time I coded this, right, I could put labels in here that says Mexico, US, rather than just the year and the numbers, right? Or before the loop starts, I could get a little strategic, and I could drop in a couple of print line statements that give me kind of a header at the top, right? And so these just print once, right? So we'll have columns. So years, the Mexico population, the US population in millions, right? And so I have a little chart there. And then a little ASCII art, to give it like a dividing line. And then we'll run the loop and I'll put all the years in the populations. And then when we're all done, I'm going to do my closer, basically. So after the loop is done, I'll put a line at the bottom so it looks like a nice little table, right? And then I will also do a little bit of output here. And yes, I am copy pasting because I want to call it a night soon. And here's the 3 statements that I put in, and I'll let you guys take your time on copying these. So the one will say, basically, here, let me see if I can just arrange my screen so I don't have to move it down a line. It will say the population of Mexico will exceed the US population in X number of years, whatever that calculation is. The population of Mexico will be this many million, and the population of the US will be this many million. And just to kind of give the user as much information as possible. The other thing I think might be helpful is maybe we get an extra blank line in there before we output this. Okay, that's the entirety of the program once again. But notice, different approach here, right? Because we don't know how many years it's going to take. It might take 5 years. It might take 100 years, right? We just don't know. We also know that rates of growth and decline change, as evidenced by the data that we already looked at. All right, so here comes the save, and here comes the run. All right, so let's scroll up here. And yeah, we got numbers here that look pretty messy, but I think it's kind of interesting. All right, so we start out, and the formatting's not beautiful, but whatever, you guys kind of get the point. I could spend the time to round the numbers and do a bunch of fancy printf statements to have it all line up. I just don't want to spend the time. But it looks like it will take about 81 years from today, if these are correct numbers for today, in order for Mexico's population to finally exceed the US, provided that those rates of growth and decline don't change, right? Now, our logic should tell us, right, that probably will change, right? Who knows? Maybe we'll have something will happen in Mexico and the birth rate declines, or something happens in the US and the birth rate goes up, or maybe the US will wisen up and allow immigrants back in or something, who knows, right? We're not to determine, but if you're worried about like there being more Mexicans than Americans, it's going to take about 80 years for it to happen, given those growth rates. So that's what this is telling us. But pretty fascinating because this is pretty useful, right? I mean, this is kind of neat kind of stuff that you can do with loops. I certainly wouldn't want to sit here and calculate this and store the values and do it all manually. The loop does all of this very, very quickly, very efficiently. And, given a little bit of effort, you can make the output look a lot more beautiful, right? For sure. All right, so that's the solution to exercise 12. Kind of an interesting little kind of data processing problem, if you will, using a while loop. Once again, we use the while loop because it's not determined how many times we want to run it. The math is going to tell us how many times. So once that number becomes greater than this one, then we stop. Just as simple as that. All right. I'm going to end the recording here. So this recording ends here.